Today we are going to learn the division, zero, and negative properties of exponents. Our target is I can simplify algebraic expressions using the division, negative, and zero rules of exponents. So let's remember what our division, zero, and negative rules of exponents are. Right, the division rule says that if I have like bases being divided, then I subtract their exponents. So I have a to the n divided by a to the m, so that will become a to the n minus m. It's always the top one minus the bottom one. The negative rule of exponents. Remember, with subtraction, we can get negative numbers, so we have to know what to do to eliminate the negative exponents. If I have x to the negative 1, then that becomes 1 over x. This negative exponent tells you that the variable or the number moves places in the fraction. So if I have 1 over x to the negative 1 and that negative exponent is in the bottom of the fraction, then it moves to the top. So the negative rule moves the spot of the base and the exponent from the top to the bottom or from the bottom to the top. The zero rule of exponent. Anything raised to the 0 power is 1. So whenever you have a variable or a number raised to the 0 power, you can make that equal to 1. And if it's multiplying by something else, then you can just cancel that out. All right, let's look at some practice problems. Alright, so here we go. We're going to simplify, and our answers should contain only positive exponents. So with the first one, I have n to the third divided by 2n to the third. So I have like bases being divided, so I'm going to subtract the exponents. Whenever you have this rule going on, when you do the rule and you subtract the exponent, it brings that base to the top of the fraction. So this becomes n to the 3 minus 3, and that 2 still stays on the bottom because that's where it originally was. Now we subtract the exponents. 3 minus 3 gives you n to the 0 over 2. Well, n to the 0 is just 1, so you end up simplifying this to 1/2. Alright, number 2. You have 3x to the 4th divided by 4x squared. Now you treat numbers like numbers. So I look at the numbers and I have 3 divided by 4. That does not simplify or divide evenly, so I keep them where they are. In our answer, we will have a 3 on the top of the fraction and a 4 on the bottom of the fraction. Now with the x's, I have like bases being divided, so I keep the base on the top, x, and I take the top exponent minus the bottom exponent. Now I do the subtraction. On the top, I'll have 3x squared, and I'll keep the 4 on the bottom. Alright, number 3 says I have 4v squared divided by v to the third. I have a coefficient of 4. I have no number on the bottom, so that coefficient of 4 will stay on the top of the fraction. My v, I'll take the top exponent minus the bottom exponent. So I'll take 2 minus 3. So this will become 4v to the negative 1. Now remember, our directions said no negative exponents. So that v to the negative 1 means take the v to the first and move it to the bottom of the fraction to get rid of the negative. So we have 4 divided by v as our final answer. The 4 stays because it's not attached to that negative exponent. Only what the exponent touches, and that's the v. So the v to the negative 1 has to go a v to the first on the bottom. Alright, let's look at number 4. I have the 3, the only coefficient, so it stays on the top. I have like base of k being divided, so I'm going to subtract the exponents. These are negative exponents, and the negative has to come into the subtraction problem. The top exponent is negative 3, minus, from our rule, we subtract them, negative 4. So now I have 3 equals, sorry, not 3 equals, 3k to the negative 3. And remember, when you subtract a negative, that actually means for you to add, or you do the change rule. So it's negative 3 plus 4, which equals 1. So this answer is just going to be 3k. All right, let's look at 4 more problems. All right, number 5 says I have 4x divided by 2x to the negative 2. So the first thing I'm going to do is I'm going to look at the numbers. I treat the numbers like numbers. 4 divided by 2 is just 2. So I'm going to have a 2 on the top of my fraction. Now I have like bases being divided, so I'm going to subtract the exponents. Remember the exponent on the top, if your variable does not have an exponent, it is 1. So I'm going to have 1 minus the bottom exponent, which is the negative 2. Remember, subtracting a negative, change rule, it's actually adding. So the answer to this is 2x to the third. All right, next problem. I only have a big number of 2, or a coefficient of 2, so that's going to stay on the top of the fraction. Like base of p being divided, so I take the top exponent of 4 minus the bottom exponent of negative 3. Again, I have the minusing a negative, so it becomes an addition problem. So I got 2p to the 7th. All right, number 7. I look at the numbers. I have 4 divided by 4. Well, anything divided by itself has 1, so those cancel out. So now all I have to look at is the variables. N to the 4th divided by n to the negative 4. You might want to cancel those out, but you cannot. One has the power of a positive 4, and one has the power of a negative 4. They are not the same. So we have to use our division rule. And we take n to the top exponent minus the bottom exponent. So it's 4 minus a negative 4. Again, the change rule will make that 4 plus 4. So the answer to this is n to the 8th power. All right, number 8 gets a little bit harder. I threw 2 variables in there for you. So now you have a number, an a, and a b. So let's look at them. My number here, I have a 2 on the bottom of the fraction. You can't bring it up to the top. It has to stay where it is. So I'm going to draw my fraction bar, and I'm going to keep my 2 on the bottom. Now I look at my like bases of a. I have an a to the first divided by an a to the third. So that becomes a to the 1 minus 3. And now I have a b to the 4th divided by a b to the 4th. You could use your subtraction rule, or you could realize that they are exactly the same thing. And when I take something divided by the same thing, it becomes 1. Just like the 4 divided by 4 was 1 over here, b to the 4th divided by b to the 4th will cancel out, and that will also be 1. So there will be no b's in your answer. Now I do my subtraction, 1 minus 3. So I have a to the negative 2 divided by 2. No negative exponents, so that I have to move this to the bottom. When I have nothing left on the top, remember I have to hold that place with the 1, because this always has a coefficient of 1, we just never write it. And then the 2 stays on the bottom, and the a squared has to move to the bottom to make the exponent positive. So my answer is 1 over 2a squared. All right, some more problems for you. Figure the more examples, the better. So number 9, I'm going to look at the numbers first. So it helps me to cover up the other stuff I'm not dealing with. Treat the numbers like numbers. 2 divided by 2 is 1, so I can cancel them out. Now I look at my x's. I only have an x on the top, so the x to the 4th is going to stay there. And I look at my y's. I have y squared divided by y cubed. So that will become y to the top one minus the bottom one, which is 2 minus 3. So when I simplify that, I have x to the 4th, y to the negative 1. Anything raised to a negative exponent has to move to the bottom of the fraction. So the x to the 4th will stay on top because it's a positive, and y to the 1st will go to the bottom. You don't have to write that first power, but you can write it if it helps you remember the rule. All right, number 10. I look at the numbers and I only have a 3 on the bottom, so I'm going to draw my fraction bar and keep my 3 down there. I have u's on the top and the bottom, so I have u to the first divided by u to the fourth, so that's u to the 1 minus 4. I don't have a v on the bottom, so I just keep my v to the fourth on top. I subtract my powers, so that's going to be u to the negative 3. Keep my v to the fourth divided by 3. And since this u to the negative 3, you have a negative exponent, we're going to move it to the bottom to get rid of the negative. So you have v to the fourth on top, and 3, u to the third on the bottom. All right, number 11. Again, you see the numbers. 2 divided by 2. 2 divided by 2 is 1, so they cancel out and they go away. And now I have x squared divided by x to the negative 1. So that'll be x to the 2 minus a negative 1. And then my y's is y to the third divided by y squared. So it'll be y to the 3 minus 2. Change rule makes that an addition problem. So I have x to the third, y to the first as my final answer. All right, in number 12, you can see we pulled in some 0 exponents. Remember, anything to the 0 power is 1. So when I look at this, I have x to the 0 power. Well, that's going to turn into 1, so I can cross that out and put a 1 there. And 2 times 1, because that's the operation that was going on between the 2 and the x to the 0 power, is just 2. So you can end up just crossing anything to the 0 power out of your problem so you don't have to deal with it anymore. So this one becomes x to the third over 2. All right, I have 4 more problems for you. Number 13, 2r to the 0 divided by 4r. So I'm going to look at the numbers first. 2/4 can reduce to 1/2. So I'm going to reduce that. I'm going to put 1 over 2. Now I'm going to deal with my r's. I see I have an r to the 0 power, so remember anything to the 0 power is 1. So that goes away. Now I'm left with my r on the bottom, so I keep it there, and my final answer is 1 divided by 2r. All right, number 14. I look at my numbers. 4 divided by 2 is just a 2, so 2 goes on the top of the fraction. A v to the 0 power goes away because it's just a multiplied by 1. Now on the bottom, I still have that u to the negative 1, v to the negative 3. As I took the 4 divided by 2, that gave me 2. The v to the 0 went away, so I'm still left with the negative exponents on the bottom. So remember, when you have negative exponents on the bottom, to make them positive, you have to move them to the top. So this becomes 2uv to the third as your final answer. All right, number 15. I have that 4 divided by 2 again. So 4 divided by 2 is just 2. The m to the 0 will cancel out because it's just a 1. So I'm left with n to the negative 2 divided by m to the negative 4. Right, there's nothing else to combine. I don't have any like bases, but I do have negative exponents, so they need to move. The n to the negative 2 on top needs to move to the bottom, and the m to the negative 4 on the bottom needs to move to the top. So this will end up being 2m to the 4th divided by n squared as your final answer. And our last practice problem for the evening. 2v u to the negative 3 divided by u to the 0 times v to the third. My number 2, I don't have anything to simplify it with, so I'm going to keep it on the top of the fraction. My u to the 0, I'm going to cross out. Remember, it's 1 times v to the third, which is just going to give me a v to the third. So now I'm left with 2v u to the negative 3 divided by v to the third. All right, so I have like bases being divided, so I'm going to subtract the exponents. So 2v to the 1 minus 3, and then keep my u to the negative 3. Do my subtraction problem there, and I got 2v to the negative 2, u to the negative 3. Anything with a negative exponent needs to move, so since both of these are on the top, they'll both move to the bottom. My 2 stays on top because it's not raised to an exponent, a negative exponent. It's just a 2. And a v squared will go on the bottom, and a u to the third will go on the bottom. And that's your final answer. All right, so after practicing these problems, we're working towards our target. I can simplify an algebraic expression using the division, negative, and zero rules of exponents. We'll practice some more problems tomorrow. Good timing. Completely done.
Awesome.
How are you doing? Did you go to multicultural day yet?
Nope.
No?
Someone was bouncing the ball in the hallway and it almost hit me and I kicked it and caught it. So now I gotta do ball.
Are they giving them out somewhere? Some people have alcohol.
Yeah. It's one of the cultures. They do it every year.
Somebody had basketball in their culture?
Yep.